enabling the digital economy.
My name is Lemia.
And I'm Nadia, and we are Team Identity Sovereignty. We are here today to tackle the issues of a lack of security, privacy, and user control in an open banking world.
These are the problems that plague a modern digital economy that still relies on physical records for identity verification.
So, we propose a digital identity solution that facilitates a new relationship between banks, customers, and other third parties.
In an increasingly digitized world where almost all of our transactions are completed online, there needs to be some standard format of a digital identity that represents a user and that can be securely verified. At the same time, we need to enable greater data sharing securely. So keeping personal data safe in an open API world requires an individual to have ultimate control over their own data. And in order to do this, we need a form of verifying who the user is. So how do you verify the identity of a customer? What is needed is a digital equivalent of a passport or a driver's license that is underpinned by your unique biometrics. The only way to have an entirely secure digital presence, void of risk of identity theft, is to link it to your physical presence. But then comes the question, who validates this identity? So open banking sets a premise for an interconnected ecosystem where the verification of identity is dependent on a network effect. In order to ensure security, the system should not be comprised of databases that each participant on the network stores using databases of customer information that each participant on the network stores, which would mean that it would be vulnerable to attacks and compromise data privacy. So instead, we use a decentralized system of trust. So what that means is that an individual's identity would be recorded on the distributed ledger in the form of public key identifiers. So the way that the network works is that with these public key identifiers, an individual can authorize any actions, and they can also prove elements of their identity to a third party. This is why the identity on the ledger is in the form of attestations, which is based on the concept of zero-knowledge proofs. This limits how much personal information actually has to be revealed. And this is, so an example is if a customer wishes to get a loan with a fintech that offers peer-to-peer loans, for example, they would need to prove that they are a reliable borrower and that they will be able to pay back that loan. However, if that fintech, for example, operates in a gray area in terms of regulation, or if they lack the infrastructure and consequently the security standards, a customer may not feel comfortable with sharing all of their personal information. So it should be enough for that company to know that the customer is a reliable borrower and that they will pay the money back. So that customer can release a zero-knowledge proof version of, for example, a credit score, which would prove that the customer is a reliable borrower, and consequently they would be able to borrow the money. So the reason this is possible is because we have identity issuers, which are reputable, trusted institutions that will verify the credentials of the customer. Consequently, this makes it easier for third parties to offer digital services because they can do that efficiently without actually having to carry the liability of storing customers' identifiable information.
So, a distributed ledger offers a new form of trust. It's ironically described as a trustless system because cryptography ensures the identity of the individual you are transacting with without revealing their personal information. As Limia just mentioned, each individual would have a unique and searchable identifier, a public key. And in order to authorize any action associated with that unique identity, you would need a digital signature. And when considering the context of an open API world where third parties wish to retrieve customer accounts, the decentralized system would enable this. And since banks and other third parties would also be on the network, it's just a matter of looking up your unique identity on the ledger and requesting access to your accounts. And in order to authorize this, you would need, obviously, a digital signature. And this digital signature is the private key that allows someone to prove their identity, and it also is a mechanism for mapping yourself onto the digital world. So therefore, a distributed ledger provides consensus for your identity, allowing validation across the network without revealing personal information and allowing you, and only you, to confirm your identity.
So as stated earlier, the decentralized system would contain identity attestations, which are zero-knowledge proofs of any claim that the customer makes. However, the actual credentials is stored in a digital wallet that the customer can access through a smartphone device. So this allows a customer to tailor access to their data, where they can share this data through a secure cloud platform to chosen third parties if they wish to.
Yep. So let's consider a scenario. A customer wants a better insurance deal with a specific company. So that company or the third party would then look up your identifier on the distributed ledger and request access to your accounts. Then the customer would receive that request in the form of a push notification in their banking app, where they will provide a read-only access to their data. So the first step is obviously to have a unique ID. However, this unique ID has to be underpinned by strong authentication. Since the basis of authorization would require that you have a private key, that unique private key would be linked to your unique biometrics.
The delivering of financial services is limited by the lack of a digital ID. The process of identifying users needs to be solved before fintechs could offer secure digital services and comply with regulation. Moreover, it also fosters the implementation of account information service provider platforms under open banking initiatives. So for example, a service that could aggregate all of your accounts and give you a holistic view of your digital presence. It, however, wouldn't require you to manually sync all your accounts to the platform, because in an open API environment and with your digital ID, this would automatically occur since all of your accounts are linked to your unique identifier.
So, in tandem, a digital ID on a distributed ledger simply makes it easier to open new accounts with third parties without having to provide personal information up front. And whatever personal financial data is required can be retrieved through the bank's API with the customer's authorization. Since a distributed ledger also sets users up with a digital wallet, they can also limit, as Limia said, how much of their identity they want to share by providing only a zero-knowledge proof version of a verifiable claim that an identity issuer provides the user with, meaning that a claim could be validated without revealing the specific data or information. Consequently, a distributed identity on a ledger also facilitates a more widespread use of blockchains on digital transactions.
So to summarize, we have a digital identity system enabled by a distributed ledger, authorization through biometrics, and then overlay services that utilize open APIs and your digital ID to verify multiple accounts. So what does this all mean in context of data privacy and security? Well, a decentralized system of trust facilitates a new relationship between banks, fintechs, and other third parties, whilst also granting greater control to the customer. It essentially enables the best of both worlds. It combines the strong infrastructure and security of banks, who would now have an additional new role of being identity issuers, with the agility and the efficiency of smaller companies in offering tailored financial services. So the essence of our solution being that whilst trust is important, whilst data privacy has much to do with trust, it equally has much to do with self-sovereignty. Thank you.